Hello everyone. In this week's tutorial video, I discuss the main concepts of harmony, as well as how to use studio effects that use multiple tracks in harmony. You may already know that when you record the sound coming out of your headphones, you will see two tracks at the same time, and this is called a stereo track, where one track is for your left ear and the other track is for your right ear. However, the track that comes out of the microphone that you speak or sing into is called mono because there's only one track, period. However, if you click Tracks and then Add New and then Mono Track, you will see another mono track right beneath the mono track you recorded earlier. And if these tracks line up at the same time, they are said to be in harmony. You can also generate a stereo track if you feel like it. But when we are working with harmony and harmony-based effects, we mostly do it one track at a time for organizational purposes. You will notice that when you click on a track to edit it, it gets highlighted in yellow at the edges. And that means the track you are currently working on. All the tracks that are not highlighted will not be affected. For example, if you said something like this into the topmost track while you had it selected, you will notice that the bottom track doesn't pick up on anything. But you can then click on the bottom track and record something, or you can copy and paste what you have recorded from the top track. When two sounds are identical, both in their characteristic and in their time, they are said to be in phase, and they will add up so that the sound is twice as loud. Like this.
Like this.
This time with the bottom track muted so you can tell the difference.
Like this.
And if you have one of the tracks inverted, i.e. that the top part is the bottom part and the bottom part is the top part, then they will add up together to cancel each other out, which is called destructive interference. Like this. Noise-canceling headphones use a microphone built into the headphone speakers that picks up on outside noise and uses an electronic circuit attached to the microphone to invert the sound wave so that it cancels out. However, note that like with the noise reduction option in Audacity, it is limited in what it can pick up on as noise. So it will not cancel out everything perfectly, as it did here. For example, a sound that continuously changes will not get picked up on as noise and will simply pass through the circuitry. Whereas a sound that has a steady and consistent sound will get blocked out by the noise-canceling headphones. If we have the sound waves at the same general phase, but with a slight difference in time, then they will add up in an unusual way, and the result will sound like this.
Like this.
This is actually the foundation of how the chorus effect works. which is not a feature in Audacity, but can be simulated manually by adding up multiple instances of the same sound wave slightly out of time with each other, and also slightly out of pitch, so that it sounds like a choir, which is actually the etymology of why it is called the chorus effect, because it sounds like a school chorus. The chorus effect is often used in studio recordings to make the sound richer, and also to give greater emphasis to it, typically used on vocals. With the pitch of the bottom track changed very slightly, it now sounds like this.
Like this.
The next effect I like to teach, the limiter, is supported in Audacity, but requires a stereo track specifically, and not simply multiple mono tracks, to get its full effect. Therefore, you will not be able to produce the sound with your microphone that will work with this. But you can play back sound through your headphones, or through your stereo system if you have stereo speakers connected to your computer, to get something like this, making sure that next to the input option, you click on the drop-down menu and then click 2 stereo recording channels specifically. Now that we have a sound captured in stereo, we can click Effect and then Limiter on the bottom menu beneath High Pass Filter, with the type at the top being a drop-down menu of 4 options: Soft Limit, Hard Limit, Soft Clip, and Hard Clip, where clip is a concept similar to distortion, i.e. that the sound at a certain volume above the threshold gets eliminated entirely, rather than smoothed out. And then 4 sliders beneath that: an input gain for the left channel, an input gain for the right channel, that was for the right channel being greater than the left channel. Here is where the left channel is greater than the right channel. And then limit 2 is the threshold for the limiter. Here's an example with a very low threshold, the minimum. And here's an example where the threshold is really high, so it's not as sensitive. The hold refers to how many seconds it will wait in terms of milliseconds before it will automatically limit the sound wave next along the time frame. Although this only works for soft limit and hard limit, the clips won't allow this option. Here's an example with maximum hold. Here's an example with minimum hold. The last option is a simple yes or no, which is apply makeup gain, where if you select yes, it will amplify sounds close to 0 decibels. Whereas if you select no, it will not apply any extra amplitude after you change it by the sliders. The next effect is the noise gate, which works similar to the limiter in concept, where the top option is gate like it would normally work, or analyze noise level where it does not apply the gate. Stereo linking allows you to determine whether both stereo channels will be affected by the gate at the same time, or whether they will be independent. The low-cut filter is off by default, but the other options are 20 Hz for every 6 decibels of octave, and 10 Hz for every 6 decibels of octave. Although this low-cut filter is only used for very, very low frequencies, lower than you can even hear. The next option, gate frequencies above, is a slider, and works similar to a low-pass filter, where the frequency is in kilohertz rather than regular hertz. So the gate will affect all frequencies above the specified point and ignore all frequencies below the specified point, just like a low-pass filter does. The level reduction determines how strongly the volume is reduced when the frequencies are gated. The lower this slider, the more the level reduction is pronounced. The third slider, gate threshold, refers to how low the audio has to be for the gate to pick up on it and reduce the level by the specified amount. The higher the threshold, the more sensitive the gate is. The final option, attack and decay, determines the ratio of how quickly the gate will apply the effect versus how quickly the gate will stop applying the effect, where attack is the formal name for the beginning of the effect, and decay is the formal name for how quickly the effect ends. The attack to decay ratio is in milliseconds rather than regular seconds. At the lowest attack decay ratio, it sounds like this. At the highest attack decay ratio, it sounds like this. The next effect I'd like to go over is normalize, which allows you to determine the peak amplitude, i.e. the highest volume, of the sound. The options are remove DC offset, which centers the sound wave along the 0 point, normalize peak amplitude to a set amount that you type in, and normalize stereo channels independently, which if checked will independently apply the peak amplitude toward the sound waves. Whereas if it is left unchecked, it will treat them both as a group, i.e. as the same sound wave. Normalization is often used with compression to make the sound more loud overall. There is another option besides normalize called loudness normalization, but since it does basically the same thing as normalize, there's not much use for it. Since I brought up the fact that normalization and compression are often used in hand, I can move on to compression next. If you click Effect and then Compressor, you will see at the top there is a graph, but unfortunately you cannot customize it. By clicking on it, you have to customize it with the sliders beneath it. The slider marked Threshold determines the volume level at which compression will begin to be applied. The next slider is the Noise Floor, which determines the maximum amount of noise allowed through. Note that it has the same limitations as the noise reduction, i.e., it will only pick up on consistent sounds without much sudden changes. So it can be used to cut out the sound of a crowd chatting if you are trying to speak clearly and deliver a presentation. The next slider is the ratio, which determines the factor of compression once it passes the threshold specified. The ratio also sets the slope or steepness of the graphic. Attack time refers to how long the compressor will wait after the threshold is exceeded before it begins to compress. And similarly, release time refers to how quickly the compression dies out. Just like the attack decay ratio in the noise gate filter. Here's an example with maximum attack time. Here's an example with maximum release time. There are also two check marks at the bottom, makeup gain for 0 decibels after compressing, and compress based on peaks, where makeup gain, when checked, applies extra amplification after the compressed audio passes the 0 decibel threshold. The compress based on peaks checkmark will amplify sounds that are louder, i.e. above the threshold, significantly less than sounds that are below the threshold. This also means that where the original volume is 0 decibels, there is no amplification applied, as the compression is based off of peaks and 0 decibels is in the center. Depending on how you use it, you can use compression to make a change in volume much more subtler than using the normalization effect. The next effect that I'd like to teach is the clip fix, which uses a technique similar to the compressor to restore audio that has been clipped from distortion. It only has two options, threshold of clipping and reduce amplitude to allow for restored peaks, where the threshold of clipping means the percentage that the volume is at compared to its peaks for it to be considered clipped. So the greater the threshold, the less sensitive it is. And reduce amplitude reduces the amplitude of the entire sound wave in order to get it away from being distorted, i.e. away from being too loud, which was the cause of distortion. The next effect I'd like to go over is adjustable fade, which works similar to the regular fades, except that it is more customizable, similar to delay versus echo. The types you can select are fade up and fade down, which work similar to the regular fade in and out options, and S-curve up, which means that it will rise steadily at first and then sharply after the midpoint, and S-curve down, which does the same thing i.e. starts gradual and then becomes sharp later on, but does it in reverse, similar to fade in versus fade out. The mid-fade adjust slider allows you to control where the midpoint is in terms of the percentage of the fade's time. So 0, the default, means midway through exactly. 100, the maximum, means it's at the end of the fade. And negative 100, the minimum, means it's at the beginning of the fade. The next option, Start End As, allows you to determine whether it should increase or decrease by a percentage of the original amplitude or by a specific decibel amount. After you determine the type the start and end points are, you can type in what exactly the start and end points are. By default, the start is at 0 and the end is at 100. But you can make it start or end at any percent or decibel amount. There are also presets, but I would encourage you to not use the presets and instead customize your own adjustable fade to get used to how it works. The next effect I'd like to go over is a crossfade, which requires there at least be more than one track, whether in a stereo like this or multiple mono tracks. And it's called crossfade because the tracks fade in and out relative to each other. If you click Effect and then in the bottom menu, click Crossfade Clips, the algorithm will take care of it for you, like fade in or fade out. And the result will sound like this. Notice how as one track fades out, the other track fades in, and that's the whole idea behind crossfade. The other option, Crossfade Tracks, is slightly more customizable, although it will not work for one stereo track, as the left and right channels are considered one track in stereo. Therefore, unlike crossfade clips, you cannot fade them into each other using crossfade tracks. You would have to record another stereo track. However, you can switch back to using your microphone and record one mono track, add a new empty mono track, and then record one mono track. Then click Effect Crossfade Tracks. And you will see the first option is the fade type with constant gain, constant power 2, and custom curve. Where the first three options have a consistency to the fade, i.e. there is no sharp drops or increases. But custom curve allows you to determine the steepness of a curve that the crossfade will follow. Here's what it sounds like with maximum steepness.
And then record one mono track.
You can determine the direction of the fade being alternating out versus in, alternating in versus out, or automatic, letting the algorithm take care of it for you.
And then record one mono track.
The next two effects I'd like to introduce use what is called a control track, or a track separate from the tracks you are working with, that is used to alter the tracks you are working with, similar to how a modulation wave works. And the first of these two effects is called autoduck, and determines which sound wave it should modulate by using the sound wave that you do not select, and then having you select all the rest. So once you have selected all the sound waves except for one, click autoduck, and then you will be prompted with another graphic similar to the filter curve or compressor. And in this one, you can adjust its points like the filter curve, except the leftmost and rightmost points you can only move left and right. You can't move it any direction up or down. And you also can't move them past the dotted lines shown on the graphic. Similarly, the midpoint you can only move up or down. No left or right movement is allowed. The center point represents the duck amount, which refers to the loss in volume. Once the control track reaches the threshold amount, the maximum pause refers to the delay in seconds between when the volume goes down versus when the volume goes back up, as shown on the graphic. The fade down length, also in seconds, determines the time it takes for the volume to decrease to the duck amount specified. And the fade up length does the opposite, i.e. determines the amount of time it takes for the audio to fade back up from the duck amount specified to its normal volume. Finally, the threshold determines the minimum amount of volume the control track needs to be before the ducking begins. As you can imagine, a greater threshold means that it is less sensitive. Here is what the autoduck sounds like.
And record one mono track.
Notice how it drops in volume initially, takes a pause, and then goes back up to normal volume. Although the autoduck might seem useless with the other tools I have introduced, it can be used to decrease the volume when you want to make an important change to the normal sound wave, such as making a voiceover for an announcement on a radio station. The final effects I'd like to introduce are vocal isolation and vocoder, with vocal isolation being the more simpler of the two, so the first I will go over. Note that vocal isolation only works for stereo tracks, so we will have to switch back to using the headphones and the stereo recording option for now. Once you have made a recording, you select the recording and then click Vocal Reduction and Isolation on the bottom menu, with the action options being remove vocals to mono, remove vocals, isolate vocals and invert, remove center to mono, remove center and invert, or analyze. Here's what it sounds like with remove vocals. Here's what it sounds like with isolate vocals. The reason this sounds differently, even though it involves no actual vocals, is that remove vocals removes vocal or vocal-like sounds from the track and leaves everything else intact. Whereas isolate vocals does the exact opposite, removes everything besides the vocal or vocal-like sounds. By similar logic, if we clicked isolate center, it will sound similar. The strength determines how strong the effect is. This is what it sounds like at minimum strength. As you can tell, the sound is already weak. So at maximum strength, it is basically inaudible. The low cut for vocals determines the minimum frequency that would be considered vocals. And the high cut for vocals determines the maximum frequency that would be considered vocals. The next option, and final option of all the effects, multi-track or otherwise, is the vocoder, which is complicated and similar to the phaser, but allows you to modulate audio using another recording rather than a low-frequency oscillating sine wave. For example, I've recorded myself saying testing and then me making the E vowel sound. Or I will attempt to use the E sound as a sort of LFO, and the testing, the sound I wish to modulate. However, the vocoder requires a stereo track, but there is actually a convenient way to convert mono sounds into stereo sounds, so that you can record with your microphone and make it a stereo sound. You first select one of the tracks you wish to make your stereo channels. Click on the other track, making sure it is not selected. Clicking the down arrow on the unselected track, where it says audio track. Then click Make Stereo Track. You now successfully combine them into one stereo track. With that out of the way, we can now discuss how the vocoder works in depth. The greater the distance, the more pronounced the original modulation effect is, like this.
Testing.
Compared to the lowest distance.
Testing.
The output choice can be both channels or right only, where both channels keeps the stereo-ness of it, whereas right only exports it to mono and only the right channel.
Testing.
That's an example with right only. The next option, number of vocoder bands, works similar to the bands in a phaser effect, and allows you to determine the number of frequencies that can be manipulated, i.e. the resolution of the vocoder.
Testing.
That was with maximum bands.
Testing.
That was with minimum bands. The amplitude of the original audio refers to how strongly the original carrier audio is presented in the vocoder. Here's an example with maximum distance, but zero amplitude of original audio. Note that nothing happens. Here's an example with maximum amplitude.
Testing.
And here's an example with in-between amplitude.
Testing.
The amplitude of white noise determines the strength of the white noise that is mixed into the signal. By default, there is none, so it has an amplitude of 0. But if you increase it to 100, this is what happens.
Testing.
Notice the random frequencies, aka white noise, present on the audio signal. The amplitude of radar needles determines the amplitude of steady clicks present in the sound, the default being 0 as well. But if you increase it to 100 and make white noise back to 0, this is what happens.
Testing.
Notice the clicks happening periodically in the sound. The frequency of radar needles works similar to the frequency of tremolo and vibrato effects, and determines how many times per second these pulses or clicks occur. The default is 30. When I increase it to 100, this is what happens.
Testing.
When I decrease it down to about 4, this is what happens.
Testing.
Notice how there was still clicks, it just wasn't as notable because there was only a very small amount. The vocoder is the most powerful studio effect because it allows you to modulate any sound by any other sound and add all sorts of neat effects on top of the modulation, such as the clicks or white noise. There are other studio effects in Audacity besides all of the ones I have taught, such as repair or spectral edit shelves, but generally they do not do anything new that we can already do with the tools I've provided for you, so we will skip those. Now that I've shown you all of the studio effects, including multi-track effects, and how stereo versus mono tracks work, I can move on to harmonic series, which is a formal and mathematical process of synthesis, i.e. creating your own tones from scratch, as opposed to editing existing or pre-recorded tones like we have done so far. Join me in next week's tutorial where we will begin doing exactly that.
Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.